Right, guys, welcome to our Friday lesson. So this is the last lesson I'm gonna do online with you guys because I will be back in school next week, and that's very exciting. Being a bit bored at home, to be honest. So yeah. Anyway, today we're gonna be talking about acceleration. Okay. So I'm not too sure if you guys have finished all the homework. So if you haven't, so next week I might give you guys a little bit of time to catch up on all those homework. And if you have, then we're just going to continue moving on with what we've been learning, okay? So don't feel too overwhelmed if you feel like, oh, yes, sir, like there's a lot of questions I'm not too sure how to answer and I've been struggling a bit. Like, don't worry, like once I'm back in school, I'll help you guys out. And I'll speed up and slow down a bit according to how you guys are progressing. Make sure that I'm looking after all of you guys, okay? So, all right, so first we're going to define what is acceleration, okay? So when we talk about acceleration, we're talking about a changing velocity or changing speed, okay? If there's no change, say stationary right now, the acceleration we say is zero. We're not changing, right? And the other situation where acceleration is zero is when object is traveling at a constant speed or constant velocity. Say if you're driving 100 kilometers per second 100 kilometer per hour on the motorway, right? And you're going straight forward. You're not changing direction either. You're going straight forward, and then your velocity stays the same. If velocity stays the same, you don't have acceleration. You're not going faster or slowing down. Okay. All right. So here we say acceleration. We define what is acceleration. Acceleration is the rate at which an object changes its velocity. Okay. So only when it's changing velocity, there's acceleration. And basically, it's just how fast it's changing its acceleration. Okay. All right. So let's have a look of the example I given you. So original speed, say 0. Imagining you are driving a car. Original speed, you're sitting there, it's 0. And you put the acceleration on, and then you become 1 meter per become 1 second later, 2 meter per second, and 2 second later become 4. And 3 seconds becomes 6, you can see your speed is increasing 2 meters per second every time, okay? So there's an increasing in speed. So we say there is a constant acceleration as 2 meters per second to the past, 2 meters per second squared, or you can write meter second to the power of -2 is the same as meter divided by second squared, okay? So that negative sign is the same as there's a divide sign there, okay? Sweet. So sometimes you'll see both of them, okay? All right, and what would the graph look like? We've talked about, okay, if there's acceleration in the distance graph, it's gonna go up, okay? And then the next thing we're gonna talk about is the speed and time graph. It's gonna be a straight line going upwards, showing the speed is increasing, okay? With 0, 2, 4, 6, 8 going upwards like that, okay? If it's acceleration time graph, it's just a straight line, okay? All right, so for the graph part, we'll talk more about it like in the next lesson, but I'll just show you guys here for now. All right, and then we can look at deceleration. Say originally 20, now decelerating become 15, become 10, become 5, become 0. So there is a -5 meters per second squared constant deceleration. If it's a negative sign, it means deceleration, okay? All right, so how do we calculate acceleration? We use the change of velocity divided by the time it takes, okay? Or we say change of time. So change of velocity is very important. You need to use the final velocity minus the initial velocity. So you gotta figure out which one is final. The change of anything is final minus initial. Okay, so you can't just use the big number minus the small number. Please don't do that, because if you do that, you get a positive number, then you don't know if it's accelerating or decelerating. So you have to use final speed minus initial speed. And then if you get a positive number, that means you're accelerating. Okay, so that means the final speed is bigger. If final speed is bigger, you're accelerating. Okay, if the final speed is smaller, you're decelerating. Then the acceleration you calculate will give you a negative number. So yeah, so that's why I have a quick example over here. A car speeds up from 5 to 14 meters per second in 3 seconds. Calculate acceleration. So we're gonna use 14 minus 5, final minus initial. That gives me 9, and then divided by the time taken is 3 seconds. So the acceleration is gonna be 3 meters per second squared. Okay, so and over here there are a few questions on your book to practice, but before you practice this question, I want to ask you one question. Okay, so and this is a right or wrong question, so you're gonna say, well, if it's true or false. Okay, so if an object have a big acceleration, Okay, have a think about it. If an object had a big acceleration, that means it must have a big speed. Or we can go vice versa. If the object have a big speed, it must have a big acceleration. You can pause the video and have a think if that's correct or not. Okay, so the answer to that question is actually false. You can have a really big acceleration, but your speed is actually still very, very small. So, and you can have a really, really fast speed, but the acceleration could be zero. Say, the example I've used, when we're driving the motorway, you're driving at 100 kilometer per hour, you're driving pretty fast, but you're actually not accelerating. You're just traveling at that constant speed. Your acceleration is actually zero. Right? Okay, so last year, me and my wife, we went to test drive this Tesla car. That's a electric car. So if you guys know me after a while, you will know like, I'm quite excited about electric cars, even though I don't have one. It's too expensive. So, but we went to this Tesla shop and just have a look of their like a cheaper model. They got a Model 3, that is a new one. But when we were there, they don't have a test drive for the Model 3, and they thought we were there to test drive the Model S, which is the super fast one. So, and we thought, yeah, sure, why don't we give it a go and then have a try. So they're very excited that we want to know this new technology, because whether we can afford it or not, they don't care. So they just want to show us this cool car. So anyway, so we got into the car and then we took it out for a drive. Okay, so from 0 to 100 kilometer per hour. For this car, it's the third, if I didn't remember wrong, it's the third fastest production car. Okay, it's not like F1, like Formula One, like a racing car or like limited number cars. So for the production car, this is the third fastest. So from 0 to 100 kilometer per hour, it takes 0.3 seconds. 0.3 seconds you travel from 0 to 100 kilometer per hour. So how does it feel? When we were in the car, it was like this. So we're on the motorway and then we were sitting there, and then the people was like, so we were driving in the like normal road, 50 kilometer per hour, and then when we were on the motorway, he was like, "Oh yeah, put your foot all the way down, then you will see how fast you can accelerate." So then I was like, "Okay." So and then I put my foot all the way down, and then went like this, and we just cannot stop ourselves but making this noise, like, and I felt like almost like sick, because like all the blood, because the acceleration is so fast, all the blood like went to the back of your head. Like it feels like that way. It's like I feel like I'm like getting sick or I'm about to pass out. And then I couldn't even accelerate to 100 kilometer per hour because it was just, the acceleration is so big. Like my body was getting very uncomfortable. So I have to stop accelerating and then slowly increase. Anyway, so we got on the motorway and then we went down for a ride off the motorway. And then we came back on the motorway. He said, "Oh, try again." And I thought, okay, I'll try again. And this time I'm going to drive to 100 kilometer per hour and I'm going to keep my foot down and just get on with it. And I put my foot down and I could not go to 100 kilometer per hour because I'm just feeling like, well, I'm about to pass out. I don't want to pass out on the motorway in a Tesla car and for a test drive and on the motorway having 100 kilometer per hour. Yeah. You don't want a passenger to pass out, the driver to pass out in this situation. So I just could not, because even though the acceleration is so big, and the acceleration, I did the calculation actually with my students, and you guys can have a try. So from 0 to 100 kilometer per hour. So pause video, pause this video, have a try. 100 kilometer per hour, change that into meter per second, and then once you change that into meter per second. So in 2.3 seconds, you can calculate what acceleration you have. And then that number will turn out to be bigger than gravity acceleration. So gravity's acceleration is 9.81, okay, on Earth. So what does that mean? It means if someone is driving that car and me jumping off a cliff, right? And that car is faster than me jumping off the cliff. So that's how fast this acceleration is. But coming back to my point, even though the acceleration is so big, but during this whole process when I'm having this big acceleration, my speed was actually not that big. The speed started from 0. or it went to 80 and I stopped. I couldn't accelerate anymore. So the speed was smaller than 100 kilometer per hour. Where rather when the 100 meter per hour on the motorway, in a granny car, say for example like a Toyota Scarlet or something, right? So you will still be driving faster than the Tesla I was driving. So this shows you that big acceleration does not mean big speed. Big acceleration can reach a bigger speed at a faster time. So, but it does not mean that the speed is necessarily bigger. Okay, so yeah, so time is a factor over here as well. So this is a part of physics like you guys have to like get used to. That's why it's so good to learn physics, because it challenges the way you think. There's a lot of common misunderstandings that we observe something, we think this is the way what it is, but then later physics or science proves us wrong. So for example, we used to think like the Earth is the center of the universe, right? Because we see all the stars moving around us. But that is actually a common misunderstanding. Like we don't think like that, because when we were kids, constantly people tell us no, like the Earth going around the sun, and the sun is just going inside the Milky Way going around, and everything started with Big Bang. But that is going because we are told so, and so people find out about it. We're told so, and then we know about it. But there's a lot of things that we haven't found out and we haven't know about, and we will constantly be told about it. So we have to part of learning physics and science in general is we have to constantly change the way we think and be able to do this analytical and find out what the truth actually is, because a lot of times the feeling we get was because of what we've taught all along, but sometimes it could actually be wrong, and sometimes we just have to sit down and say, hey, what is the truth? So we have to rethink everything and remap our brain and joining some new neural pathway so that we can understand the world we live in better and make the world a better place. So yeah, and as you are learning physics this year, you will see there's more and more of that, and next year, the year after, there's just gonna be more and more. And you realize wow, I didn't know that. That was so cool. So that's how I feel with physics, and also a lot of previous year students felt about physics, learning physics at a higher level. So for example, time and space, we think time don't change, right? So we think time, okay, 1 minute, 1 second, 1 second, 1 second, my watch is going, but actually time could slow down or speed up according to how fast you go. Say if an astronaut going to space and then come back, he will be a bit younger than us. Time passed slower for him than for us because he's traveling really fast. And that is a matter of fact. It's been proven, and we actually need to use that every day in terms of satellites and communications and supercomputers or even normal computers. It's lots of things that we just it's actually very different from how we think they are. So yeah, so it's a fascinating world and very exciting for you guys for this year. So, and I'm looking forward to see you guys next Monday. So hope you guys have a good weekend and get lots of homework done, and see you guys soon. Okay, bye.